You need to understand how memory and data and remanence works in order to understand how to work with and dispose of the hardware when we no longer need it. Data remanence is whatever is left over after we do a normal removal and deletion of data. And all data is just zeros and ones. Ones are off, zeros are on, and that's the bits we use for our data. Memory works the same. Each memory switch represents a 0 or 1, which is the bit. In our systems we have many different types of memory, where cache memory is the closest to the CPU. It's also the fastest. A level 1 cache would be on the actual CPU itself, and a level 2 cache would be connected to the CPU, but outside it. You'll also often hear the terms volatile and non-volatile memory. While they are similar, they're also very different. Let's look at the non-volatile type first. Non-volatile memory keeps the data it has stored even if you power it off. This could be ROM, read-only memory, which really isn't as read-only as it suggests, but the initial types of it were. A PROM, or a programmable read-only memory, can only be written once. This would normally happen at the factory, and these are the early versions of ROM. Over the years, people realized it didn't make sense to have them like that, where you can only write to them once, because you can never update them. If you wanted to update the system, or a vulnerability was discovered, you'd have to replace the whole ROM. The next version was the EROM, which means erasable programmable read-only memory. It can be erased or flashed, and you can write on it multiple times. Each time you just need to flash it. For the EEPROM, that was done by shining an ultraviolet light into a little window on the chip which would normally be covered by foil. The ultraviolet light would erase the memory on the chip, and you could then write it again. While this is no longer done, the EEPROM is not really used anymore, but we do still use the term flash the memory. What we use now is EEPROM, which stands for Electronically Erasable Programmable Read-Only Memory. It's a bit long one by now. What makes this smarter is that it's electronically erasable, which also makes it more dangerous. To flash the memory and update it, you just need a flashing program, which then can also be used by the attackers. Since the ROM is one of the first things that starts up on a PC, way before the actual operating system, this is like a lot of other IT security issues. The easier we make it for the user, the more vulnerabilities we'll open ourselves up to. Programmable logical devices, or PLDs, are programmable after they leave the factory. That would be the EEPROM, the EEPROM, and other flash memory, not the PROM. You'll probably never encounter the PROM, and very unlikely the EEPROM, but for the exam, understand how each type works, their strengths and vulnerabilities. Volatile memory is a little bit different. It will only keep the data it has for a short amount of time after losing power. This would be random access memory or RAM, and they can either be the sticks that you slot into the computer, or they can be embedded on the motherboard or hardware. Static RAM or SRAM is the fastest type, but also most expensive. It uses latches to store bits that are also called flip-flops. What makes it different than other RAM is it doesn't need to keep refreshing the data. The data is kept until it loses power or it's overwritten. An SRAM chip can be embedded on a CPU, for instance, or on a graphics card. Dynamic RAM or DRAM is slower and cheaper, and it uses small capacitors, and they have to keep refreshing the data to keep the data integrity. Somewhere in between 100 and 1000 milliseconds, it has to refresh the data over and over and over to keep it active. DRAM can also be embedded on the graphic card or other hardware that needs dedicated memory. DRAM, this is normally what we put in the memory slots on a computer. They can easily be removed and replaced. For most of us, those would be DDR RAM, 1, 2, 3, or 4, but you might run into older versions on older systems. When we talk about firmware, that's the low-level operating system configuration that will be on a computer, router, switch, or whatever hardware we have. On a PC, it would be the BIOS. It's the low-level operating system that tells the system how to boot up and launches the higher-level operating system. This could be Windows, Mac OS, Linux, whatever you run. The firmware would be stored on an embedded device, and the memory would of course have to be read-only memory. Common firmware chips could be PROM, EEPROM, or EEPROM. You'd mostly see the EEPROM today. Flash drive or flash memory are small portable devices. A USB stick could be an example, and they use EEPROM. SSD drives also use EEPROM and DRAM. They're much faster than regular spinning disk hard drives, but it's worth noting they can't be degaussed. So when you dispose of them, if they're functional, you can overwrite all the bits on the drive. If not, destruction really is the only option. Most commonly used would be shredding.